Right, so this is the Year in Science. I am Dan Dworkin, the moderator. I am a bioinformaticist, researcher at the Altitude Research Center at the Institute's Medical Campus. And we're going to be talking today about kind of the things that have happened over the past year in various scientific fields that we think are just really kind of interesting or cool or scary or whatever. So let's go ahead and introduce ourselves.
I'm Rebecca Lickis. I write science fiction and fantasy, obviously. And my day job is I teach physics at the Air Force Academy.
I'm Arlen Feldman. I'm a software guy. I, until recently, ran development for a fairly successful software company. And now I bum around.
That sounds something we all aspire to. I'm Mike Carroll. I'm an astronomical artist, a science journalist. I have 26 nonfiction books out and a novel this year. And just love Mile High Con.
I think we all love Mile High Con.
Yes.
I'm Will McCarthy, and in addition to writing science fiction, I was a contributing editor for Wired magazine for many years, and for a 10-year span I was the science columnist for the Sci-Fi Channel, which was a fun gig. And I hold 28 US patents, and I've been the chief technology officer of 2 different companies, and I'm the VP of technology of one now.
So I guess to get started, maybe let's just, if we want to each just throw out 1 or 2 things that have happened in the past year, not in our fields or otherwise, that we think are just really significant groundbreaking news, and then kind of go from there. So. Or should we start? How about we could start at this end of the table?
Okay, well,
do you want to go ahead and kick it off?
Sure, absolutely. I think the one that's really caught my attention most of all is Alzheimer's disease. I think, Alzheimer's is one of the scariest diseases. I think that probably everyone in this room has a healthy fear of Alzheimer's. And so I've been, for my whole life, kind of eyeing the press in that area. And progress in understanding that disease, much less fighting it, has been agonizingly slow. But this year, there have been breakthroughs on a number of different fronts. About 10 years ago, a bunch of medications came out that were able to slow the progression of Alzheimer's disease for the first time. And that's a big deal, slowing the progression, prolonging quality of life for people who have the disease. But what's happened this year is that for the first time, several different drugs have been shown to reverse the effects of Alzheimer's disease. Not 100%, it's not a cure, but it's a treatment that actually moves the clock back. And that's a huge, huge deal. And it comes from finally these 3 drugs that I'm aware of each have a different way of attacking the disease, but the big breakthrough in understanding, I think, is that like so many other illnesses, Alzheimer's turns out to be fundamentally inflammatory in nature. Alzheimer's has these protein plaques that build up in the brain and clog everything up. They're made of a protein called amyloid beta. But it turns out that those plaques are not the disease, they're not the cause of the disease, they're not even a primary driver of the disease. If you break up those plaques, it doesn't do a lot for the benefit of the people suffering from the illness. If you instead put anti-inflammatory medications in the right places, and that's not easy to do because the blood-brain barrier tries to keep as many things out of the brain as it can. But anti-inflammatory treatments are effective against Alzheimer's disease, both in reversing it and also in preventing it from happening in the first place. So there may be something. Years ago, a doctor friend of mine said, take a baby aspirin every day and stay the hell away from doctors. And this may be added to the list of reasons why she was dead right about that.
Well, there's so many people already taking a low-dose aspirin a day that I assume, is that where the data came from?
That's where some of the data came from. I don't want to say more than I know. I've just been remarking that for the first time, people are able to turn the clock back on Alzheimer's.
Great. All right. Well, about a year and a half ago, as you know, the Chelyabinsk meteorite came down, or meteor. It didn't quite make it to the ground except in a few little chunks. But that was a dramatic wake-up call. 1,500 people were injured. We are now up to about 1,400 near-Earth asteroids that we have clocked and charted. So this is something that I think is going to be on the radar screen. Also this year, hopefully, yes. So to speak, yes. Right. We visited a comet this year. Amazing images from the European Space Agency of P67. This essentially is the year of Pluto, which is why I wore my Pluto shirt. Over this coming year, we'll be having data trickling in from the New Horizons spacecraft. We've seen blue skies and lovely icy mountains and methane, nitrogen glaciers, and it's a wonderful and far more complex world than we thought it was. And since there are at least 200 worlds about that size out there, it really opens up some fascinating fodder for not only scientists but science fiction writers.
I have to ask, Adam, has anyone ever said, we got to this planet and we got a close look at it, and it's much simpler and more boring than...
People did say that about Uranus when we got there.
Yeah, that's true. That's true. Yeah, okay.
The press called it the most boring planet in the universe, but it turns out that it's not as boring as it was. Hubble has unveiled all kinds of exciting weather activity, if you get excited about weather, out there, because it has passed its equinox and the lighting conditions have changed. So the atmosphere is doing all kinds of things that are more like the other gas and ice giants.
I think they just wanted the headlines.
Yeah, probably so. Nice sound bite.
Yeah. Plus, anytime you could say Uranus, never a bad thing, right? As the least qualified. I have a couple. One to me is the prevalence of 3D printing. I mean, obviously it's been going for a few years, but things are really starting to heat up. Not only is it from a hobbyist perspective, I mean, you can now go to Sam's Club and buy a 3D printer, which I think is crazy. But things that people are doing with 3D printing. This year, they're doing human trials of printed bone. There's a 3D printer on the space station, which they actually printed tools that have been being used on the space station. They're printing tissue with blood cells. They're printing liver cells. You can't actually print a liver yet, but they're printing liver cells that they can test various drugs and things in. And they think that they're not that far away from being able to print liver. They're printing skin, which can be used for burn victims and won't be rejected because it's based on you.
What kind of toner cartridge are you
You go to Office Depot, you buy a liver.
Yeah.
Don't get them mixed up.
I would avoid the generics in that.
You never know where the livers come from.
And there's all sorts of other things. They printed replacement for people. The person had their skull damaged, and they replaced the skull. Titanium parts, as well as doctors just sort of printing models of the parts that they're based on MRI data that they're going to work on, so they can practice ahead of time, which seems like a good idea to me.
Even simpler than that, Arlen, don't forget about casts. 3D printed casts are huge these days.
Oh, right.
Yeah.
In 5 years' time, no one will ever have a regular cast ever again. The 3D printed casts are exactly fitted to your limb, and they're porous. They're mostly, they look like spider webs. They're mostly empty space, so you don't have that awful, shut-in feeling for months.
They've also, this is not in human trials yet, but heart valves. So,
Let me tell you about it.
Sorry, I worked on a heart valve project. That is one of those problems that seems like it ought to be really simple, and just
yeah, all you have to do is build a valve that will operate 60 times a minute
under
every
enormous
hour.
pressure
Yeah, forever. No problem. I don't see why that would be a problem.
Engineering problem.
Exactly.
And it's not allowed to fail for more than a half a second or something.
Yeah. So I think 3D printing is huge. I think the other one is renewable energy. At this point, the U.S. is generating 14% of its energy through renewables, which is dramatically up. I mean, it's been going up almost a point a year for the last few years. Most of it's still hydro, but wind is making big inroads. Solar is almost up 1%. But the Elon Musk project that's they're pre-selling now, I think is going to be. I think we could probably just have an Elon Musk version of this session of things Elon Musk is doing. But they're working on basically a home battery that's powered by usually solar, but also can take power off of the grid, and will power your house at peak when it's needed or when it's low requirements. And it's about $3,000 for this system, which is very, very inexpensive.
That's really, I think, what's needed to make powering your home by solar practical, right?
Yeah, and China is putting a huge amount of investment into solar right now. For some reason, they thought it would be nice to see the sky without having to stop traffic for 2 weeks in a row. So those are sort of my two big biggies.
The Germans are big on solar too, and if you've ever been to Germany, there's no fucking sunlight there.
Denmark, last year, Denmark generated all of their power internally. They imported nothing.
Wow.
And most of that was solar.
I always thought it'd be poetic if the Netherlands were to go back to using wind power to pump out the lowlands. But they're trying to do that.
For personal reasons, I have spent the last 2 years obsessing over cancer, and it's really amazing what they are doing now. They have got treatments now that are specifically targeted to your specific cancer, so that you can take this, it's basically chemotherapy, but you don't get sick. Because it targets just the cancer cells, and the chemotherapy that, traditional chemotherapy, it targets everything, and that's what makes you so sick, and your hair falls out, and all that kind of stuff. But now they've got coming in the works, and some already out, that specifically target specific molecules or pathways or things that your specific cancer does, so that that medicine goes in, targets that cancer, kills the cancer, and leaves most of the rest of you alone. And that is just so exciting. So exciting.
A lot of that is targeted immunotherapy.
Some of
the
it is,
idea
yeah.
is we want to get our immune system. Cancer represents a failing of the immune system, of course. And so if we can get the immune system to target cancer cells, there has actually been a couple of cases where that's actually worked too well.
Yeah.
There was a patient who had, I believe it was advanced metastatic melanoma. So it started out as a skin cancer, but it was throughout her whole body, and she had huge tumors, internal tumors, in her lungs and in her abdominal cavity, and the immunotherapy wiped it out in something like 2 weeks, which of course is wonderful. But now she's kind of hollow, and she's needed like multiple rounds of surgery to keep her body together, because the tumors were essentially part of her body structure at that point. Better than dying.
Also, so it did not go on to attack her other tissues.
Right, exactly. It's
But
very
It
specific.
knew when to stop, at least.
Yes. Oh yes.
Oh, good.
Another thing they've targeted is the cancer cells, the the way they replicate. And once they've become cancer, apparently they actually replicate. They have a different chemical and physiological system to replicate than regular body cells. So they're trying to target that, so that instead of killing off every cell in your body that's trying to replicate, they just go for those specific cancer cells.
Just for reference, when you put weed killer down on your lawn, what that's doing is targeting the plants that grow the fastest. It's toxic to all of the plants, but it's less toxic to grass than it is to tumbleweeds, because tumbleweeds shoot up overnight. Chemotherapy follows basically that same sort of weed and feed principle. It's pretty unnerving when you think about it.
It's sort of interesting because, of course, a lot of the aging process is the breakdown of almost the same process that works in cancer, where the cells are where your DNA strands are sort of getting extended and replicated properly. And if you can figure out a way of making that happen without
starting the cancers.
yes,
Yeah.
that would be helpful.
Well, so actually, this was not one of the items I was going to bring up, but I believe this was published within the last year. If not, then not much more before that. There is a protein called MYC. I can't remember what that's an acronym for, MYC, which is a growth factor that's important in all kinds of fundamental cell division and development processes and developmental processes. We know that this protein is absolutely vital. If you don't have it, then like in a developing embryo, then you don't get a viable embryo. But there is a strain of mutant mice that underexpress this protein dramatically. And this is the amazing thing about these mice is they are normal mice. They develop normally, but they are very long-lived. They hardly ever get any kind of cancer, and they are healthier and more active and more athletic than most mice. I don't know if they won the mice Olympics or what. But I mean, right, exactly. And so and one of the hypotheses is that they're basically their cells are they're slower growing. They're slower. They're doing everything slower, so it's slowing down the aging clock, and they simply don't die of these old age diseases. Was there any other items you wanted?
Well, I wanted to bring up that they're studying elephants actually.
Yeah,
Because elephants almost never get cancer, and they have
Neither do
more
sharks.
cells in their body than any other land animal. They have more cells, and the more cells you have, the more likely you are to have something go wrong. As a species, in general, on average, your mileage may vary, kind of thing. But they would really expect, with the size and as many cells as elephants have, that cancer would be extremely common in elephants, but it's not. So they're looking at how the elephant's immune system works and what it is that elephants do that stops the cancer in them.
They just don't stress.
That's actually why my daily regimen is a baby aspirin and an elephant every day.
Okay, you win.
The elephants eat their fruits and veggies.
They get stuck in your throat though.
Right, you gotta drink a lot of water to wash the elephant down, right?
It gives whole new meaning to the elephant in the room.
So there were a couple of things that other items, unless you had.
I know, that's it.
Okay, that I wanted to talk about. Two closely related developments from my field, and then one outside it. So the two big stories in the genetics world over the last couple of years. One is CRISPR. Probably people have seen this acronym, CRISPR. I cannot remember what it stands for, and I'm not even going to try to explain the biochemistry because I understand about 10% of it. But the big picture is that this is a new genetic manipulation technique, which is like thousands of times more precise than anything we've had before. People have been trying to build genes from the ground up or alter existing genes on the nucleotide by nucleotide level for ever, pretty much as long as we've understood DNA. This is the closest thing that we have ever come up with to being able to take a pair of really tiny tweezers and move a base pair or base pairs around and insert or delete them where we want them. This is a huge thing. There's been an explosion already in research, and honestly, I think probably applications are only a couple of years down the road at this point.
They just used that to insert woolly mammoth DNA into an elephant.
Yes. Yes.
Finally,
It always comes down to the elephant.
Is this on 2 years?
So I don't think anyone can say for sure where this is going to lead, but it's going to be a tremendously important technology for us soon. The other one that is most directly related to my work is we finally have the $1,000 genome. This is a thing that we can finally say we have. About a year and a half ago, Oxford Nanopore released a new kind of sequencer, which basically, rather than the methods used in most other sequencing projects like the Human Genome Project, where you break the DNA up into a bunch of fragments and you sequence those fragments and you do all kinds of computational tricks to reassemble it. This basically reads the entire chromosome. You feed an entire chromosome through this nanopore, through this very, very small hole, and it reads each base pair as it goes, and it has to do this with several thousand replicants because it's not perfect, and you still need the computational stuff to kind of smooth out the errors. But the point is, this is a system that exists. It is in hospitals right now. There's a few big research hospitals that are now routinely sequencing every patient who comes through the door. And with consent. I mean, you can opt out, okay. But most people don't. That's the thing. Vanderbilt really pioneered this a few years ago. They basically have the check-in forms, and they explain. They say, okay, if it's okay with you, we're going to do this. And most patients say, okay, sure. Which means that we are now building up this enormous amount of data on the combination of gene sequence and phenotype. In other words, we now, you have this enormous database of here's all of your cancer patients, here's all of your diabetes patients, here's all of your asthmatic patients, and here's their genetic variants, and here's what makes them different from.
So it costs $1,000 per patient?
$1,000 per patient. And if you consider that the Human Genome Project sequenced 21 sequences at the cost of several $1 billion over the course of 12 years, and this is $1,000 in a matter of hours.
Wow.
So that is huge, and this is already something that people are doing right now in the field, and has already had some real impacts. A few years ago, the FDA finally approved patient-specific doses of warfarin, which is an anticoagulant drug. It's used for stroke patients. This is kind of one of my where were you then moments. I was at the conference where that was announced, and people were just flat. But that was the first one, and now there's like 10 drugs that are that way. We talked about obviously with cancer and other very individualized diseases. So that is kind of for my field. That's kind of.
It was a mistake to major in physics. That was so 20th
Well,
century.
I've said this, that I really feel like biology right now is like where physics was 100 years ago. We are living, this is the age of whoever will be the Einsteins and the Heisenbergs and so on of biology. They're out there right now.
I've got a couple of other biology things. It's interesting because everything on my list is biology related too. There has been tremendous progress. I did want to take one moment to say that they stuffed us in this little corner room here where the comic book panels have 3 times the space. I'm very heartened to see that it's standing room only in here. Kudos to you, our audience. A couple of interesting things. These are nowhere near the size of what Daniel just talked about, but exercise in a pill is something that looks like it might actually happen. I think not this year, but I think that we're starting to figure out exactly what the physiology is that will allow that to be possible. Now, this dovetails with other research. It's been known for a long time that calorie restriction, very similar to the mice that Daniel was talking about, a calorie-restricted diet. This is a completely healthy, balanced diet, but with a reduced number of calories, basically a starvation diet. Mammals that are fed a starvation diet age very slowly. They're probably not very happy. There are some humans. There are humans that have tried the calorie restriction diet, and they report not being able to think very clearly and other side effects like that. But as it turns out, now this is an interesting breakthrough that happened quite recently. Most of the effects of calorie restriction happen very quickly and persist for a long time. So it turns out that 5 days of calorie restriction will carry you through 6 months. It creates changes in the immune system that last. So you can think clearly and have all the energy that you want while still getting the benefits of calorie restriction. Now there's another piece. I think I might be the only person that put all these pieces together. It turns out that the actual physiological benefit of calorie restriction comes specifically from restricting the amino acids that contain sulfur. So it's not even necessary to restrict the entire diet. It's only necessary to restrict three different amino acids, I think. So I have this theory that if you restrict those amino acids for 5 days, every 3 or 4 months, you can live forever.
Wow. So are you going to try this? Are you going to go on a 3 amino diet?
I absolutely have plans to try this. I haven't quite got around to it yet, but it's
I assume that the label packaging covers that all.
It's in the diet book that will make you a millionaire.
Right.
The amino fast.
Right, yes, amino, that is brilliant. That's a great idea.
By the way, the exercise in a pill thing, they're also working on little bitty earbuds so that it's, on a treadmill you listen to music, take this pill and you can hear music too. It'll be great.
So right tied to that, they're just starting trials on replacement lenses, kind of like cataract surgery, but it will give you 3 times better vision than 20/20.
But no. You
have to have
that's an aftermarket. Yeah. So the other thing that I wanted to bring up, which is maybe not as directly important as all of this medical stuff, but I think is fantastic. Brontosaurus. It's real.
Back.
It's real. Yes.
It's angry.
But the process.
It's not called the Metagenomics?
The Metagenomics is real too. So this is actually the process by which this happened is actually something that's really important and has kind of deep implications. So in biology, I mean, most people here, high school biology, you probably had there's species and there's genus and there's order and there's class and all the rest of it, the Linnaean hierarchy. And that's really been replaced over the last 20 years or so by what's called cladistics, where groups of organisms are divided into what are called clades, which are groups of related organisms. Now, some of those correspond very nicely to the species and genus and so on that we're familiar with. But it turns out that it's a much more flexible way to order things. It's based on similarities, whether those are genetic similarities or anatomical similarities or whatever. You say basically, well, this animal is more similar to this other animal than either is to this other thing. So we're going to put these two in a group together, and then we're going to put this other one in a larger group, and so on. And over the last 10 years or so, all of this has been computerized, and not just obviously like in my field in genetics. I mean, one of the nice things about genes is that it's actually fairly easy to define similarity measures between genes. But paleontologists, for example, have put an enormous amount of work into defining similarity measures between the anatomical features that we can get from fossils, which of course is mostly bones and teeth and so on. And you put this into these programs that are designed for the purpose of splitting groups of organisms, and you can come up with these really deep insights into the evolutionary history of the organisms and how similar or different groups are. And in the case of Apatosaurus, the story is that Brontosaurus was named, or Apatosaurus was named first. Another specimen was then named Brontosaurus. And then a few years later, someone came along and said, no, these are really the same species of creature, so Apatosaurus was the older name, so it took precedence. But for some years now, there's been a group of paleontologists saying, we have all now enormous numbers of these fossils of Apatosaurus, and here is this group over here that looks rather different from the others. And they finally did this very sophisticated cladistic analysis and said, yes, there is a distinct group of fossils within the general Apatosaurus group that really ought to be in their own genus. They're different enough to be in their own genus. And one of those is the fossil that was named Brontosaurus. So, ta-da! Back. And of course, yes, this just makes my inner 8-year-old very happy. It also makes my inner 46-year-old very happy because this means that we have gained this kind of real insight into evolution.
Now, if we could just make Pluto a planet again.
Well, Alan Stern, from what I understand, is working on that. I think the New Horizons data gives him a lot of.
We were supposed to get 12 planets, not 8.
Yes.
Promote new members.
Going
not
the wrong
get
way.
rid of
Yes.
members.
Another paleontological news item this year. Up in Phillips, Montana, they've been working on a lambeosaur whose soft tissues are very well preserved. And I think they're about to publish a paper on the face, which they've just finished. There's been a long debate about the structure of dinosaur faces and whether they had buccal fat pads or whether they were more like crocodilian structure. So this one may shed some light on that, but a new one has been discovered, I think in Utah, and so stay tuned for information on the duck-billed lambeosaurs.
All dinosaurs had sideburns.
I'm terrified to bring this up on a panel when Will's sitting 2 seats away from me, but from the physics perspective, there actually has been a lot of stuff going on with quantum teleportation and quantum entanglement in the last year. And I hate to say it as I'm going to avoid committing to anything while I'm saying this, but one of the things that they managed to do, for example, is they managed to transport more than one characteristic at the same time. They managed to teleport information about spin and angular momentum at the same time, and they think they could actually send more pieces of information at one time, and that philosophically could move us towards the supposedly impossible quantum communication type stuff, where you could send data without having to worry about, speed of light lag. They've also managed to create quantum entanglement on a silicon chip. So it used to be that you had to do lots of really painful things with lots of huge, expensive equipment, and now they think they can just sort of have a chip that will entangle hundreds of photons at the same time, which I believe not only would be useful for some of these other things, but could potentially be useful from the perspective of quantum computing. So, and also much cheaper and much easier.
That's too much work.
I think we're.
I'm a physics professor here, but
yeah.
That's too much work.
Just to say a quick word about quantum computing. There was a brief burst of excitement early in the year about quantum computing, and I think that it's turned out to be mostly vapor. I think that we're not quite there on quantum computing.
is D-Wave, are they like a gigantic fraud, or, I mean?
No, I think that it's absolutely legitimately true that D-Wave is exploiting quantum effects. What has not yet been demonstrated, and may not be, is that D-Wave is capable of solving practical problems that we care about faster than a standard computer.
Can you explain D-Wave right quick?
We could do a whole panel on that. D-Wave is a quantum computer that's commercially available. The government is the main customer for these, although Google owns a D-Wave. And there is a lot of excitement around D-Wave, but I think at least the Rev 1 D-Wave that we have right now isn't doing what we hoped it would.
one of the interesting crossovers between computing science and physics is someone's actually figured out a way of doing computing using DNA, where they encode sequences of DNA, put it into a beaker, stir the beaker, and then measure the solution of the problem, not just the solution in the beaker. And it seems like a very strange thing to do, but there are certain classes of problems that quantum computers are also sort of good, particularly to do with cryptography and large number math, where what you want to do is sort of take a whole huge number of possible solutions and stir them up and come up with a solution. So that might be how the NSA is reading your email.
I gotta say, I'm really.
They're reading actually all possible email.
They know, they can calculate the probability distribution that you will send this particular. I gotta say, I'm really skeptical about DNA computing as anything more than a stunt. I think it's cool. Yeah, it's cool stuff, and I think it'll probably help us understand how information processing happens inside living systems, and that's certainly a valuable thing to learn. But I really don't see it as being a computing application.
Well, maybe your DNA will be your 7 billion bit encryption key.
Right. Well, the problem is though there's too many repeats.
Yeah.
One of the things they are using DNA now is to spray down pieces of art and footballs and basketballs.
Yes.
So that you can authenticate it later on that this was a piece of art created by the artist, or this wasn't all used.
Yeah, and again, this is one of these applications for fast sequencing, because this is the sort of thing that would have been absolutely prohibitively, insanely expensive, even 10 years ago, and so now it's practical to do that kind of thing.
It's a whole different panel to discuss all of the terrifying side effects of all of this.
Let's talk about this. So we've talked a lot about, this is really cool, here's this neat new thing. There's in science fiction, of course, ever since the genre's beginning with Frankenstein, there's been this whole, are we going too far? Do unintended consequences? What do we? I personally am going to say right now that my bias is to say full speed ahead. Damn the doubters, full speed ahead. But what are some of the things we have to worry about here?
Female Viagra. Civilization will crumble.
It's got stiff
Dream
competition.
Being sold in Canada right now.
And it don't work.
I have to admit that 3D printed smallpox has been a little concerning. For one thing, I'm having real trouble getting the nozzle to.
What are they using that for? To make blankets or something?
The problem is, the design for smallpox is more or less readily available. The technology for printing custom viruses and so forth viruses are probably further out, but bacteria,
Yeah, it's probably a virus is actually probably one of the simpler things to assemble. We can't do it quite yet, but soon. I think.
Could they engineer, say, a virus that attacks redheads? Looking for a particular gene sequence.
Why are you asking?
Because apparently I am not doing a good job as moderator here. Thank you. Very reassuring. I don't know. The answer is I don't know. It would. There are certainly viruses which attack certain segments of the population. There are diseases that certain people with certain markers are vulnerable to. Most of those are cell surface proteins. And so I would say the answer is if, for example, the particular allele that causes my variety of red hair, because there are 3 or 4, were associated with a cell surface protein, then maybe so. You know, it wouldn't be that it would go after redheads. It would go after people who had that particular protein on the surface of, say, their lung cells or some other vital organ. And if it's
so much
strongly
better.
associated, then that would be pretty close. Yeah, no.
I also think that biometrics, so we're getting to the point where, doing a full sequence is $1,000, but, you know.
But that's not what they charge the insurance company. It's
I'm
much
sure,
higher.
right. But for doing the basic sequencing, for example, the medical, when they're trying to determine if you killed someone, they're doing what, 21 points of comparison or something?
Well,
Which
that
is,
increases.
that, I think that they've recently upped the legal standard to like 50-ish.
Okay.
Which is an absurdly small number.
Right,
Yeah.
but biometrics, everyone was thinking, oh, it will be so much more secure because you can do your fingerprint or your eye scan or your DNA. But the flip side of that is, if someone steals your identity, it's really hard to change your fingerprints. Or your DNA.
Right.
And of course, once that data is in the system and people are using it as your identity. So it's actually kind of scary because we sort of rush ahead and I log onto my phone with my fingerprint, but...
There have been cases where people have been convicted of crimes committed by close relatives.
Wow.
And this is a problem.
Well, there was a contamination case in Texas.
Yeah.
And they were checking 16 points of DNA, and they were saying the chances of this match is like 1 in a billion, and no, it was a small inbred community, and the chances.
Right.
were
So
like
there you go. Yeah, what do you do when everyone is first cousins? But I know that there was one case recently. A guy, I can't remember where it was, but the guy got out of prison after like 15 years for a murder committed by his brother. And the only
Well,
way
that's going to be an interesting family reunion.
but the only way that they were able to do this was with better sequencing technology, because at the time that he was convicted, the legal
Yeah, it was a
standard, the
16-point
21
match.
points or whatever was enough to convict him. But then when they redid it, they were able to say no, this wasn't you.
I just say the other problem with biometrics is they do change.
Yeah.
Yeah. Right.
You get your biometrics done, and then you go back, and it's like, no, that's not you.
I know of a woman worked at a military base down in the Springs. One of her coworkers told me this story. She discovered she was pregnant because the biometric scanner would not let her in because her eye.
Oh wow! Okay.
And alarms started going off, and people with guns.
Right.
Yeah.
It's a boy.
I can just see it now.
Okay, we have a question back here.
So I heard an NPR report recently about antibiotics in the livestock industry, and the doctor on there said that we are almost now at the same position concerning treating bacteria that we were pre-penicillin.
Oh,
As
yeah.
things are becoming ineffective. But then I heard some, as a sidelight to that there are new treatments that aren't antibiotic treatments for bacterial infection.
So there's a couple of, I'll take this unless anyone else wants to. Okay, so there's a couple of parts to that. One is, it's an exaggeration to say we're back to the pre-antibiotic era. Most antibiotics are still effective against most of the things that they always were effective. I'll grab
With like 2 or 3 exceptions.
But it is true that resistance is becoming a huge problem. And there are frighteningly large numbers of strains out there that are in fact resistant to everything we can throw at them. The antibiotic research pipeline is starting back up again, finally. I don't know of any new antibiotics that have actually been approved.
One just came out.
One just came out, but there are bunches more in the clinical trials.
But there's like, what, 5 now? 6 now?
5, what, 6?
I mean, penicillin, erythromycin, and...
Oh no, there's more like 100.
Bunches.
There's bunches of psyllins, there's bunches of mycins, but the pipeline's starting back up. We're starting to get new ones, but yeah, it's going to be a problem for a while. There have been some interesting alternative, the bacteriophage approach, which I think is just really, really cool. There are viruses that target only bacteria. They're called bacteriophages. And you read World War II technology. Yes, and it was largely dropped after the success of penicillin and some of the other early antibiotics, because everybody said, we don't need this, this messy, complicated stuff with viruses when we just have this nice chemical. But so yeah, there's a lot of really cool research going on with bacteriophages, and there might be some other.
I know they're looking at a lot of people with chronic infections, like sinus infections, they have a biofilm that is formed in their system. And they're looking at ways to target to get rid of the biofilm, because then the antibiotics become more effective, because the biofilm helps to protect the actual bacteria inside the film, so that the antibiotics are not actually getting to them. But if you can get rid of the film and the stuff that's protecting them, the antibiotic is effective again.
Right. So we had.
I actually, in my microbiome class, we just got done testing samples of water from different parts of basically Jeffco County. I want to say 4 out of 5 grew antibiotic resistance bacteria. And these were from just outside normal water samples.
Yeah.
Oh, wow.
I know my sample in particular, like the entire plant grew. And there were at least 7 different kinds of bacterial cultures that were.
So basically, avoid your neighbor.
As long as you stay out of Jeffco, you're fine.
Yeah.
You did say Jeffco?
Yeah, that one was in Jeffco, but we had students from all over, like Aurora and whatnot. So,
Oh dear.
and it's, our data is actually coordinating with CU Boulder, so we should be seeing that research coming out from CU sometime in the near future.
Okay.
Oh, wow.
Different colleges around the
By the
state.
way, there is a big. It's no longer as big as it was because the guy who founded it left to go to I think University of California, San Diego. But there is a big metagenomics group up in Boulder. So these are people who study basically what they call the metagenome. I talked about all the ohms on Friday when we were there, but this is basically all of the genes that are present in an environment, like say a water sample, right? And you take this and you don't say, well, there's this bacterium and there's that bacterium and this kind of amoeba and whatever. You just basically just say this chunk of water has a genome. Because a lot of these organisms trade genes back and forth all the time, including things like antibiotic-resistant genes. And so you can almost kind of think of it as one organism with one genome and looking at that kind of...
I have a sort of a, maybe it's a little early for a closing thought, but one thing that I wanted to throw out while we still have the opportunity here is that observing the future, science fiction writers and science journalists are in the position of kind of watching for the future. We've got our trip lines out, and we're always on the alert for it. But I'll give you an example of a time when I was right and a time when I was wrong about observing the future. In 2003, I was at a conference called Hackers, where they were talking about social media this, social media that, and I wasn't getting it. I didn't understand the significance of what they were talking about, and I didn't understand why they wouldn't shut up about it, because there were other things that I wanted to hear about. And now social media has completely transformed our landscape. It's transformed the way that most people live their daily lives. And so that was one that I missed. That was one that I should have understood at the time that I heard it. On the other side, I was asked in 1997 by Connie Willis, actually, to write a short piece on what I thought the most significant science development of the year was. And a lot of big things happened in 1997, but one that didn't get a lot of press was the development of the blue LED. For the first time, somebody had made an LED that was capable of producing blue light. And I said, this is going to change everything, and it has. You can't turn your head. In this room, you're going to see blue LEDs everywhere, your phones, everywhere you look. Most of the small screens that you look at these days are LED-based screens. A lot of the very large screens that you see are LED-based. It's only the living room-sized screens where we haven't quite conquered that frontier. But that's an example of, I would encourage everyone here in the audience to when you hear a new science story, think about what that really means and think about, roll that out into the future.
Yeah. We have a comment in the back.
Yeah, I kind of wanted to go back to Will's comment earliest about the inflammation and the biofilm. One of the prevalent biofilms in the body is in the mouth. And you can go to your dentist or your hygienist and they're going to tell you to floss and brush your teeth, But the leaps and bounds in dentistry have been incredible in the last 20 to 25 years. and we've actually connected the different bacteria in the mouth, and there's over 600 named kinds, and we believe there's over 1,000 different ones. And of course they work as a biofilm community, building the first, electrical system and so forth. But what we discovered is that the biofilm in the mouth, under the gums, is connected to heart attacks, strokes, diabetes, asthma, pneumonia, Alzheimer's disease, rheumatoid arthritis, kidney failure, problems with certain cancers in men, impotence in men, prostate inflammation, problems with pregnancy like stillborns, miscarriages, premature labor and birth. So, it's just an incredible amount of interconnections with the rest of the body, and we're finally back to connecting the mouth and our brain to the rest of the body. And so I think that when the hygienist asks you to floss, you know now why.
Right.
Well,
yeah, looking at living systems as systems. That's been a big thing. There's even people talk about systems biology as a phrase now.
Although I strongly deny that my mouth and my brain are connected.
You win again. Okay, so real quick, I think we're all the way back in the far corner.
No, I was just getting your...
Oh, was that the 5-minute warning? Okay, so we have, I think, maybe one time for one more comment. And then
I've seen lots of things that suggest that aging, people are going to live much longer. What is your thoughts on how soon is it going to be somebody lives to be 150 or 200 years old?
Hopefully after all the baby boomers have gone.
Two of them are standing right back there. I would kind of like to see them stick around.
Not if they want to collect Social Security.
Well, okay, that actually, I think
We can't afford it.
Yeah, I think we can, but that's really a whole other. Yeah, I mean, okay, who knows? It may be that there is a hard limit, that there is a clock that we can slow it down, but we can't stop it. It may be that aging is a curable disease, and I don't really have a feeling on it.
And if you believe in brain curve, well, you've got until 2049 that the technology will make it anyway.
Yeah.
So, quick question: aluminum air batteries? Anybody excited yet?
I think we need a whole separate discussion.
Yeah, I think we have just hit time. So really great discussion. Thank you.